So, behind me is a really interesting photo. How many of you have been staring at it trying to figure out what it is? For the folks who are at Hackathon, by the way, I told you yesterday, so you can't say. But so how many of you think you know what this is? Oh, I got some hands. Let's try. You were the first. What do you think? Schema of what? Of what? No, it's not the repository. I'm sorry. Any other guesses? Warmer, but not quite right. We'll do one final guess. It is an ERD, but an ERD of what? That's the prize question. So the answer is actually, this is my life for the last 2 years at Tableau. This is the entire metadata model of Tableau Catalog. You can see my Tableau Catalog shirt, and you can see what Tableau Catalog looks like under the covers. Today we're going to be talking about the Metadata API. I have a Tinder logo there because it's also all about the relationships between content. Who am I? So I'm Tyler Doyle. I'm a product manager at Tableau, and I've been with Tableau for about 8 years. It'll be my 8-year anniversary in December. You can blame me for a lot of server-facing features over the course of my tenure: project-controlled permissions, revision history, the UI refreshes in 10, data source certification, and then most recently, one of the 3 PMs on Tableau Catalog. But specifically, I worked on the API and platform team for Tableau Catalog, and then the lineage widget, of which I'm so proud and glad it made it onto a t-shirt. To prove I'm a real person, though, here's a snapshot of my life. You have me hiking with my girlfriend at Franklin Falls. You have me eating avocado toast, as any millennial would in New York City. And just a mural in New Orleans from last year at TC with Jean Miro, one of my favorite modern artists. Today we're going to talk about the Metadata API. And I titled this talk the Metadata API Deep Dive for a reason. I mostly just wanted an excuse to geek out about what I've been working on for a year and a half. If you're here for a tutorial or a how-to or an entry-level talk, unfortunately that's not what you're going to get from me right now. You're just going to get me nerding out, answering questions, and having some fun with the API. If you want a tutorial or a how-to or an intro to GraphQL, I am giving that talk 3 times, once today at 4, and then tomorrow at 12:30 and tomorrow again at 4. So you can come to the hands-on training if there's still room and take a look at things there. I want you to leave mostly inspired today. Inspired to go try out the Metadata API. Don't worry about the tutorial, just jump in, see what kind of interesting questions you can answer with Catalog, and get really excited about the platform functionality that we've introduced to you. Also at the end, if we have some time, I do want to do a Q&A, because I think you'll all have a lot of great questions that pop into your mind, and I'm totally open to dedicating a large portion of the talk for that. But first, let's come back to this wonderful mess here. So this is the metadata model for Tableau Catalog. This is everything that you can query through the Metadata API, and by extension, this is a lot of the stuff that shows up in the Catalog user experience. Of course, no human can actually make sense of this, so it's a little better to think of Tableau's metadata model like this. You have a bunch of content types on your Tableau server. Data sources, workbooks, and prep flows might be something you're familiar with. And then we've extended that to include things like databases, tables, and files. We also have things at a finer level of detail that you might not think about all the time, like the fields inside your data source, the columns inside your tables, and the sheets and worksheets inside your dashboards and views. So what is the Metadata API? It's not just a list of content types, obviously. It is a GraphQL endpoint that's built to expose all of these objects to you and try and be able to answer any crazy relationship type question about them that you might want to ask. What is it for? Why do we have a metadata API? Is it just job security for me? No. Primary use case is lineage. We have all of these relationships so we can track the lineage between all of the objects that you care about and even the ones that you don't. Do you want to know what worksheets are connected to a database? Do you want to know if there's a prep flow and an intermediate in between there? Do you want to know how many calculations have been created based on a particular column? All that type of relationship or lineage information is available through the API. Of course, that means you can do impact analysis. If you can go up, you can go down in our graph. And you can programmatically discover assets, which is a fancy way of saying that you can combine this with the REST API and other APIs in the Tableau platform to do some pretty crazy use cases. I do have a script at the end that I will show that's kind of a fun demonstration of that. Who can use it? All right, who gets the Metadata API? The good news is anyone who has Tableau 2019, Tableau Server or online, 2019.3 or later can use the Metadata API. It is not required that you have the data management add-on. You can have your lineage information for, not free, but the cost of your regular license. There is a caveat though. The functionality is a little bit limited without the data management add-on. So if you have Tableau Catalog and data management, you can read that metadata and the lineage queries and all that, but you can also push useful metadata like data quality warnings, certification, contacts, and descriptions. If you want a really good demo of that, you should hit up the showcase where they're showing off the Tableau Catalog UI, and you can see the sort of writable metadata stuff. But we're focusing mostly on read today, which you get for free, as long as you run a TSM command to turn it on. So you do have to turn it on. But it is available for anyone with Tableau 2019.3 or later. So let's go back to some diagrams. Where does all of this metadata come from? If you're familiar with the Tableau server or online ecosystem, we have a bunch of files of different types. Tableau workbooks, affectionately called TWIBs, Tableau TDSs, or Tableau data sources, and then, of course, recently the Tableau prep flow as well. So when you activate your metadata API, what we do is we kick off a process called backfill, and here's where the nerding out begins. So you kick off backfill. We have a couple of new processes that are running on your server. They're going to go through and open up every workbook, data source, and flow in your environment. They're going to extract all of the field level metadata that they can out of those documents. And they're going to do some really cool things, like if it's a calc, then they can go ahead and grab all of the fields underneath it, and they build up all of the relationships within the Tableau content types. How many sheets are in a dashboard, what dashboards contain what sheets, which contain what fields are on those sheets, this whole kind of mess of a graph. Then we also take a look at all of the physical assets that those are connected to. So of course, workbooks don't just exist in a vacuum. They connect to probably a table or multiple tables in a database somewhere. We go ahead and we grab all of those references and all of the columns that we know about in those objects. We do our best to deduplicate them and build a nice, beautiful graph representation, and then we store that back in our Postgres repository. But for those of you who are really excited about going and connecting to the Postgres right now, we are not in the workgroup database. We're in a new separate database instance running with your Postgres. That is a graph abstraction layer. So it's not really designed for humans to connect and build data models off of. You're going to see a bunch of node tables, a bunch of edge tables, and a bunch of vertice tables. You are welcome to connect and try and make sense of it, but it's going to be crazy. It's also going to change all the time because it's an auto-generated schema. So really the way to interact with this is through the GraphQL API that I'm going to show you. So after we've gone through the backfill process, we then go ahead and run through the graph one more time, and we pre-compute a bunch of interesting paths for you. And what do I mean by an interesting path? Well, let's say you have a table, and you want to know how that table is used in your organization. And specifically, you want to know what worksheets it appears in, a column from that table appears in some way. Is the path table to worksheet? Do you drag a table onto your worksheet in Tableau Desktop today? Get some head shakes there. No, you don't, right? What do you drag out? This is audience participation time. Drag out a field, that's right. Does the field exist inside your table? This is a trickier one. I see a no, that's right. The field doesn't. The field could be a calculation that you created yourself. The field references columns that are inside a table, and then of course the columns inside the table. So your link is table to column to field to embedded data source in the workbook to worksheet. That's like 5 things to remember. It'd be painful if I made all of you write all of that the whole time. So what we do is we go ahead and someone, mostly my team, figured out all these paths and pre-computed them and built them into the graph. We call those shortcuts. They're one of the most powerful features in the API, and when we get to the code portion of things, that's what I'm going to focus on a lot. So when we run through, we compute all the shortcuts, we store those, and then the backfill process is done. From that point forward, you have a Tableau catalog or a metadata API repository ready to go. And every time you add new content to it, we just ingest that single item, kind of repeat the process, but just for that one item recompute the shortcuts that are necessary and toss it in. So it'll keep up to date with a lag of generally under 5 seconds. All right, so I've teased a lot about the GraphQL API. Let's do a very quick tutorial just so that you guys can see what I'm talking about. So this is GraphQL, very confusingly named. Notice this I in the middle. This is not the type of endpoint. This is just the name of a free open source tool that we ship with in Tableau Server. So I'm going to show you how you can get to it. If you have Tableau Catalog, so you're sitting on your Tableau Server page, you can jump down to External Assets. You can click this link, and it takes you to this built-in tool that I've got. If you do not have Tableau Catalog, but you have activated the Metadata API, you can still get here by just going to this bookmark. So what does this tool do? Well, it connects to the GraphQL endpoint. GraphQL is defined by a schema. So that thing that my team and I very painfully and painstakingly designed out for everyone, that sits on our server. This tool connects to it, and it automatically builds up a nice interactive experience to query it, as well as built-in documentation, which is always a hit, at least with me. On the left side, we will type whatever kind of query we want, and on the right side, we get an answer. The way GraphQL works is you kind of type a JSON object without the values. So you tell it what you want the JSON back to look like. So let's do something simple. Let's do all of the published data sources on this server. Let's grab their name, hit play. Now that everyone's watching, I think the Wi-Fi is going to be uncooperative, but we'll give it a second. Just get a little disconnect and reconnect, and we also can activate the backup plan, which is to have my phone's Wi-Fi ready to go. Ah, it came back, good. We did not have to go to the backup plan. So on the left, you type out a query that you want, and on the right, you get it back in a nice JSON-shaped object. It can do a couple of really cool things. Everything in GraphQL is strongly typed, and so you can use that to pick out just the pieces you're interested in. For example, the way that you would do a join, a list of fields to a list of published data sources, is you just say, hey, give me the fields. Let's grab the project name as well. Hey, give me the fields, give me their name. If we run it, we will see in this data source, lovely named after a test server here, we've got our project and we've got our field names. But if we're interested in certain types of things, we can just tell the query to only care about those types of things. So let's not actually grab the name. And let's say for calculated fields only, let's grab the formula and an actual reference to those fields. And if those fields are calculated fields, I want to grab their formula. And you can go on ad nauseum. But if we hit play here, we will now, oops. Let's just hit play again. Oh. It's too big a list. Let's refresh the page. Let's just go one level deep and grab the ID. So if we run it on the right there, we'll see eventually a field. We'll see every field, but because we only care about calculated fields, it's ignoring them until we get to a calculated field inside a calculated field, in which case I'm getting my results back. You can start to see how you can combine this in some pretty interesting ways. Let me do just a couple of more examples, and then we'll hop back. Let's talk about physical assets for a moment. So published data sources, we all know and love these. These are Tableau content type. You create them in Tableau, you delete them in Tableau, that's where they live. but they reference external assets. They reference fields, or they have fields, which might be what we call a column field, or it's pointing directly to a table, there's nothing interesting about it, it's not a calc, it's not a bin, it's not a set. So if it's a column field, we can look at the column, and look at the column's name, and we can see all of the physical columns on our server and what fields they're behind. This is cool. This is kind of what the Catalogs UI lets you do. But we can go a level deeper. We can grab the column's data type, or we can grab only calculated fields hit the formatter there. This will, and remember, the whole point is not to teach you GraphQL, I'll come to the tutorial for that, but this will go through and show you only the columns that are used in calculated fields, ignoring when it's used kind of in a one-to-one regular field. Hit play, and boom, you've got an audit of all of your calculations in a few seconds. But how do we do that link? Like, what is the actual crazy data model? I'm going to recreate part of that graph for you. So let's go ahead and go from a database table, a nice innocent database table, here they all are on my server, down to a worksheet. What are the ways that we can do that? Are there any guesses? Like what hop would I have to make from a table out? What was it? That's right, column is the first thing. So our columns are fun little guys, but they are referenced by fields. And then I can just go to data source, and this will only show me workbooks. It's a way to just get workbooks. And so here's all the workbooks, right? Anyone have any idea what we might have missed there? Is there another way to get to a table from a workbook? Huh? Publish data source, that's right. All right, so there's another path we have to go there. Let's go ahead and just kind of hit that one down, and let's go again. So how do we get to a published data source? Well, if it's referenced by a field, fields can be in published or embedded data sources. But if it's in an embedded data source, which is a, let's see, this is a direct one. So if we can go to a published data source, how can we tell? Well, one way to do that is just repeat what we wrote down here. And if it's a published data source, then yeah, sure, we can grab the published data source's name. But we want to get to the workbooks that are behind the published data source. So how do we get to those? Well, we can referenced by remote fields. And then inside the remote field, we are now in the workbook. So this is a data source field. This is the workbook field that references it. Let's go ahead and grab its name. But we're actually still only part of the way there. Because think about it, if I've got a published data source and my published data source is pointing to my table, what can I put inside my published data source? Bins, sets, calculations. Calculations aren't going to point directly to the column, they're pointing to something else. So we have to grab those calculations. How do we do that? Well, we do this again, we do reference by fields, and then if it's a calc, we can grab its calc there. But of course, it's not just fields. We could also be inside a set, so then we have to grab the set. And then I'm fast forwarding a little bit, but actually you have to do this path multiple times. So you start copying and pasting these sections into each other, because you can go from a table to a published data source to a workbook, but the workbook could have a calc that's pointing back to a field in the published data source, and you kind of get into this crazy world of recursion. I don't have the full one ready to show you, mostly because I'd have to show you the source code to do it, and I'm not supposed to do that. But trust me, it gets to be about 80 some odd lines long. So what's a better way to do this? Let's go back to our top level database tables. downstream, workbooks, name. Done. So that's what a shortcut is. It takes away all the hard work of trying to figure out every possible path to get between each object. These are the core of what the Metadata API platform does. Every content type on Tableau, instead of you having to figure out how a metric when those are introduced have to work their way back to a table, or how a prep flow relates to a worksheet, or how a worksheet relates to a dashboard. That one's kind of easy, but we still calculated it for you anyway. So you can go absolutely maddeningly crazy and do things like, I want every database table's name, I want every downstream worksheet's name, and then for each of those worksheets, I want to find if anyone has created, you know how you can type a calculation directly onto the shelf? Well, we capture those as well. So if you want to get those, then we can grab the worksheet fields, and then we can grab their name, we can grab, and you can go on and on. You can actually even do some really weird stuff, like find me all of the database tables whose name is, I think Starbucks is a common name on this server. Yep, all right, so we've got all the database tables with the name Starbucks. Find me all the downstream sheets. There's 2 downstream sheets, so that one has a max of 2, great. So I want to find the version of Starbucks that is the most used on this server. This is where another fun thing that we do for you. So far, all right, let me back up. See, I'm getting so excited, I'm all over the place. Let's back up a little bit. Right now, everything you're looking at is just full lists of stuff. But of course, if you have a billion tables or a trillion tables, you're going to crash some computer somewhere trying to query all 1 billion at once. You might want to filter, you might want to grab pages. So we pre-calculate a bunch of pagination stuff for you, and it's all in the schema. So to figure out how to do it, you just have to remember one word. How do you paginate? The word is connections. You type in what you want to paginate, like database tables, and then you type the word connection after it, sorry, just the singular form of connection there. And then it looks the same so far, but you can give it the parameters to tell it what you want to do. So if you just want the first, I don't know, 3, then you want to order them by, let's say, the ones with the most columns. There you go. Oh, and then field columns count. Make sure you give it a direction because it really wants to know. So we want descending direction there. And there you go. Those are all of the tables with the most columns. So maybe I want the biggest Starbucks table, but how do I know the number of columns? Well, how do we get lists of things again? I just told everyone, so this should be easy. The word connection, right? So columns, connection. We have a special property called total count. Total count aggregates the number of things in the list. Now we're starting to do a little bit of math here. So I can run this query again, and there are 2,048 columns in a table named sheet with 2,048 columns. You can tell this is a test server. 281 here and 281 there. And we could also flip it to the other direction. And we get, some tables with 0 columns, which can happen in custom SQL cases, which is probably going to be a Q&A question later. So we'll get back to that. So now that we have this ability to filter, we have the ability to page, we can join things kind of by just asking for references. You can start to ask around, like, all right, what are all the database tables? Let's see, database tables connection. I want to sort these by, and everything has this wonderful autocomplete, the ones that are most popular. So the ones with the most workbooks that are somehow connected to it. Direction. We're going to do it descending, so we'll get the most popular ones. We'll run it. We will make sure that we finish typing out our query here. We'll run it. We'll get the IDs. Great. And now I want to grab the name, and I want to grab not just the columns connection, so not just the total count, but I also want to grab the name of 3 columns in those tables. Well, we can do something called aliasing to get really creative. So we'll say count of columns. Let's give us the total count. And then we'll just get column names. And we will actually grab those columns. We'll only grab the first 3. We'll sort them alphabetically. Grab the column names here. We'll run the query, and here is in order, and this is a mouthful, so bear with me. Of all of the tables on my server, the ones with the most workbooks, the first 3 columns alphabetically. Now that sounds like not a very useful query. It sounds like something I just made up, but the reason I'm showing it to you is because that's the query that we run to show you the UI. If we jump here, we jump to tables, and we sort by workbooks descending. That's the exact query that we use to give you this columns column, which helps you disambiguate between tables. So you can see that everything in catalog is built on top of this API, and everything in catalog is sort of built on this concept of graphy relationships and joins. Let's jump back to the PowerPoint really quickly because I want to make sure I cover all of the fun stuff I was going to. So we've done fields and columns, we've talked a little bit about the data model, we've talked about connections. Let's talk a little bit more about filters. Talk a little bit more about filters. So, in addition to be able to arbitrarily nest any object you want, any relationship you want, you can filter them down. Something that I have heard very often is I want to find all of the fields or all of the calculations named something, right? So let's go ahead and, because I don't have a demo set up for it, let's like improv a demo. Let's find first all of the calculated fields on my server. Here's their name. Let's sort by name so that we can see them grouped together. Okay. 111, that's not a great name. Accounts. Number of records isn't very exciting. Oh, there's one, sales per customer. We see a lot. Where was that? Ooh, selected graph measure. That, I don't even know what that is. So now that I've done that, we can restart it, do calculated fields. We can filter to anything we want. We can do one item here, or we can do a list of names and grab those. So we can do that. Great, here's all those. Let's grab their formula and see what kind of formula it is. All right, it's got 3 fields in it. Grab those field references, and we've got them there. So this is probably a parameter, which I'm not going to add in now because I don't remember the parameter path. But so we see a bunch of fields, we see the calculation we see here. You can filter at any level. So what if we only care about, now that we've learned about SCI budget, for example, let's do that. Let's do SCI budget. And we are filtered down to just SCI budget. Oh no, except I probably need a space there, and it's back. So we've kind of narrowed into something and we found it together, but we can also go back up. And you can do this down and up traversal as much as you want. So let's find out where this comes from. Let's say upstream columns. What's your column name? You come from a column. So we had some automatic data modeling on this guy. And then what's the table that you're in? The table is in something called National Ad Sales Leaderboard. Well, where else is this table being used? You can just keep adding questions into your GraphQL as you go deeper and deeper into it. So let's say downstream workbooks. What are all the workbooks? So these are all of the workbooks that use the table that the column SCI budget comes from that I found by picking a random calculated field on my server. Let's talk about permissions. I'm an admin on this server, so give me a second to log into one where I'm not an admin. Great. So this is actually the dev server that we use at Tableau to track like our bug counts and our sprint burn downs and things like that. So All of this metadata is great, but I've been running it as an admin. And the reality is most of us in the room, even if we're data engineers or we're in IT, we're probably not admins on our server, because then we'd have access to everything and nobody has access to all of the data. So how do we handle the case when, let's say, there's a table that I want my users to know about, but there's a sensitive data source that I don't want them to know about, but then there's a worksheet that I do want them to know about because it's tightly controlled. You don't want lineage to break in the middle there, because then someone who manages the table might delete the table and it breaks this very sensitive data source and suddenly you've got a call from the CEO. So we introduced a new type of permission just for the graph called obfuscated permissions. And the principle is really simple. If you have permission to see something, you have permission to know that it's related to other things, but you might not necessarily know what those things are, just that they exist and who owns them, so you can hopefully email them. A great example of that, if I go to, let's do database tables connection, and let's just do the first 500 so that I don't go too slow. Let's pick a table here. Fact opportunity. Nope, that's probably a test one. Here, this sounds. Build details view. I want to find like a real data set that's not so real that I get in trouble for showing it to you. Actually, let's just use the UI. Let's cheat a little bit here. Oh, I was looking at the wrong table anyway. You're right. Okay. First 100. The only downside of that whole connections thing, which is a GraphQL standard, by the way, is that like weird little nodes in the middle there. All right, so here's a good example to start. I run database tables connection. I'm asking for the first 100 tables, and I see a bunch of null named tables here. Now, why are there a bunch of tables with nulls? It's because I don't have permission to see that table's metadata. Someone, for some reason, has decided, or was too lazy to add me, or they've decided that I don't have permission to see that table. But they probably have workbooks underneath them that I can see. So, go in here, run downstream workbooks, and we'll see that's actually exactly the case. I have no idea what this table is named, but I do know that there's a downstream workbook called Customer Data Repository. And I could probably grab that owner's name and say, hey, what's this table that you're using? If I can have access, I think it would be really helpful. I love your viz, and I want to copy it. So we have this system where we let you know about things, but we don't let you see if they have a contact. We don't let you actually go to it. You can't see its downward metadata or anything like that, but you can see things that are connected to it. And so this is basically just a blanking out system. But depending on what you're trying to do, if you just want to get a list of every workbook that you have access to see, you might not want all of those nulls in there. You also can't really tell the nulls apart, which is by design, because if you could tell them apart, you would know what they were. So we have something called permissions modes. We do database tables. Something called permission mode here. The way this works is really simple. You can say, obfuscate results, so give me back everything you can, just hide the things that I'm not allowed to see. Tell me that the node exists, but hide its name from me and hide its link from me. Or filter it out. Pretty simple. See, here is a list of database tables filtered, and here is a list of database tables obfuscated. The way this manifests in the UI is like this. Sign me in again. There we go. I might have permissions to everything on this table. I've got to jump back one. So in the UI, that ends up looking like this, permissions required. And so then the user will know that there is a table there, it's being used by some stuff. I can go find workbooks that are connected to it if I need to go ask someone, but I can't actually go and investigate it and see metadata that I'm not allowed to see. All right, we've hit all of the major ones. Now we get to putting it all together into some crazy use cases. So, because I know one of the first questions is going to be, how can I find all of the custom SQL tables on my environment? What kind of custom SQL support do we have? Here's a query to help answer and demonstrate that. Let's go ahead and jump to this server here. So this query takes a look at every database, finds every custom SQL that references it, and then it goes ahead and it jumps down and it grabs either the published data source's name or the workbook's name. And so I can use this to find where custom SQL is being used in my organization, and if I want to, and in fact I included it in the query here, will actually include the query text for me. So I can use this to go and audit custom SQL. There we go. See if we can find a good one. Here we go. Here's one where we're using some, and we can go ahead and go take a look at that published data source. Here's a big one. And that one is in a workbook. Another example, using a bunch of those features that we did earlier. So big I had to comment it out myself here. This differentiates between going from a table directly to a workbook versus going from a table to a data source to a workbook. Now this is not something you probably want to actually do in practice, but you can do something called aliases, and so you can issue the same query multiple times but with different filters or with slightly different attributes, so you can aggregate them however you want. So this one here, if you want the direct, it's really easy. Look at the fields. If it's a workbook, grab its name. The hard way to do indirect is kind of what we typed out earlier. Look at the fields again. If it's a calc, if it's a published data source, then jump to the workbook and then look at the fields again. And then I need to copy and paste this inside itself to get it correct. And at the end of that, you get all of the workbooks that are either connected with one hop or with multiple hops. But again, remember, the much better way to do this is like this. Name. But we can run the query here, and I probably, let's just do that. There we go. And here you can have a JSON object with direct versus indirect workbooks, and because it's JSON, you can copy and paste it and plop it into Tableau, and you can filter it and analyze it just like you would any other JSON data source. That is the end of the main section. I kind of wanted to dedicate a healthy time to Q&A. What we do not have is a microphone, so what I'll have to do is do the one headphone on, one headphone off, and then I'll repeat it back. So it'll be like a simplex repeater. So, question, we've got to, go ahead.
So all of the code you were just running here could also run the API calls, Python scripts or whatever, get the data back out automatically, right?
So the question was, all of the stuff that I'm running in the IDE here can be run elsewhere. I don't have to write some sort of weird script that always calls this web page, right? The answer is yes. So you can call it as a direct API endpoint, and I actually have a little bit of code that does just that. If you're familiar with Tableau Server Client, it's a library that wraps the Tableau REST APIs. I added support for sending metadata queries. You can see right here. You can just send these. It uses the API endpoint. This happens to be Python, and then you get the JSON object back and can do whatever you want with it. Great question. So the question was, how long does that backfill process take? The answer is, it depends, because it always does. But it scales with the amount of content you have and a little bit with how complicated your graph is. So for our internal test server, which has something on the order of 4,000 published data sources, 10,000 workbooks, and 80,000 worksheets, it takes about 6 hours to run the process. And this is a tunable thing. You can up the number of threads you have running, you can up the amount of memory you have dedicated to this background job, and it will accomplish it a little bit faster. But the neighborhood of 4 to 8 hours is what it seems to be for large deployments. For the first time. And then it is incremental after that. You do have to rerun it every upgrade. So like when you upgrade to 19.4 from 19.3, you'll have to do it again. We are looking into automating that process, but there will still be that downtime.
When you say upgrade, you run
You do from 19.3 to 19.4, but not from 19.4 on. We automated it for you after 19.4, which I realized just came out yesterday, but the dev team's always a couple of months ahead. So it'll run in the background. The application is actually designed to run completely, acceptably while that process is running. The only thing that will happen, let's do a really quick query here. Let's do the name of every, let's do. So GraphQL returns all of your data at the top, and then at the bottom it will return an object called errors, if there are any. The way we work while backfill is running is we just return what we have. So if it's 1 minute into backfill, it's going to be pretty empty. If it's halfway through, you'll have at least half of your stuff in it. We'll return the data that we have, and then we will send a warning that says, hey, backfill's still running. Then your code can check and decide to hang out for a while and try again. Or it could even pull looking for that warning with a simple query to see when it's safe to operate. The UI actually does something very similar, where we'll just return the data that we have, and you'll get a little notification up here that's dismissible that says hey, not everything has been computed yet. Any other questions? Sorry, back row, and then I'll come to you.
The existing metadata still be maintained, and it's also for how long? Like if we have stuff built already using stuff in workgroup, will that still exist? For how long?
So the question was, what's happening to the existing metadata in the workgroup database? And for those of you who don't know, the workgroup repository is sort of the main Tableau server data store for today. We exist alongside it. We are not replacing it in any way. Workgroup's primary purpose is to be the database that runs Tableau server. It's like the operational database. It happens to also get used by a lot of illustrious engineers and Tableau server admins to be sort of an analytics warehouse as well for certain things. But we're not touching it at all. And we actually consume some of the data from it to store in ours. So it'll be there forever. And then you had a question? Say that again, sorry.
So I would be interested to get all workbooks that contain user filter or data source. Is it possible to get that?
Yes. This is kind of a challenge query question. So would it be possible to get all the workbooks that have a user filter? And the answer is yes, using that up and down technique that I mentioned. The way you would do it is you would say, give me all the calculated fields with a formula you'd have to be a two-step process. So you would have to script it a little bit. But you get all the ones with the calculated field, and then you would scan for the user filter properties, which would be is username, is member of, is member of group. And then you would grab their IDs, and then you could filter that into a second query that filters to those IDs. It would look like, let's see, I did say that I would do a challenge. So let's look like that. And then you'd have to have Python code or something that goes through here and grabs everything that actually, no, wait. Yes, okay, actually we have a property built in for that. So it's a lot easier, I remember now. You just look for ones that has user filter is true, or has user reference is true. That basically automatically sets a flag whenever a user filter is in play. Then you grab the workbook name, data source, you grab the workbook name. And copy and paste that JSON into Tableau, filter, you got them. Other questions?
Well, two questions. One is, the first one is the metadata scoped to a site or can the catalog see across sites? And the second question is, you know how if your solar index gets suspect, you can rebuild your solar index? Same sort of thing.
So the two questions. The first one was, is the metadata scoped to a site or a server, or how does that whole thing work? The answer is it is scoped to a site, because that is how we can give you permissions. And that obfuscation system I mentioned, it has a partner called Derive Permissions, where we automatically calculate tables that you should be able to see because you've published content that can see them. And so the only way to really safely do that is within the scope of a site. Although you can log into different sites via API and merge data if you want to. Second question is, can you rebuild the index a lot like you can rebuild the Solr index? And the answer is yeah, rerunning the TSM command will rebuild it. It will also kind of rebuild itself over time if you just like publish the workbook again. It'll rebuild that part. Other questions? Oh. Instances being like a server or site. So related question, we actually have this at Tableau. Internally at Tableau, we have sites for different, or servers for different region. So the queries will be the same. The beauty of GraphQL is they're all using the same schema. And so you take this query and you can run it across any of those instances. There's no like automated way to do it, but because it can be like scripted with something like TSC, you would do something like for site in list of sites, run query site, and then merge results. That's probably the most efficient way to do it at this point in time. We're investigating trying to streamline that cross-site boundary.
Can you identify within a data source that has multiple data connections the joining conditions between those connections?
So, meaning a blend or a join? A blend or a federated data source?
So within data source, multiple data connections.
Yeah. So the question was, do we handle like multiple connections within a data source? For example, a Teradata table joined to a SQL Server table. And the answer is, yep, that's completely fine. And the question he didn't ask, but I thought he did, was, can you handle blends? And the answer is yes, we can also handle blends.
No, sorry, I meant to say if you have the details of the joins.
Don't store the joins. So we do not store the joins themselves in the graph currently, although that is one of the things that we're looking at adding in the near term. But we do grab everything from the join, if that makes sense. So we'll know that these 4 tables, no matter where they are in this data source. There's a question here, and then there's one there. Okay.
Yeah, just one question for those metadata information. They store not under workbook database, right? It's under different database.
Yep, the database is lovingly named relationship. So they're in the relationship database. There's a question there. The data source, sorry again? Yes. Can you do dashboards and stories? This is a great advanced question. So we have dashboards in the graph. Here they are, and here's their name, and here's all the dashboards. Dashboards themselves actually don't have anything on them. Dashboards are just objects that contain the sheets. And so all you have to do is jump to sheet, and then from there you can get the fields, you can get the columns, tables, whatever you want to grab there. So it is all in the graph. Stories? Stories are not yet in the graph. However, a story is just a container of dashboards. So if we had stories, it would look like this. Story, dashboards, sheets. You always have to get down to the sheet because that's where the actual data model has been built out. Any other? Oh, yep.
Yeah, we are connected to a database, not a database, but Dodo, and the backend is connected to Snowflake. Is it possible to write and the data that we have from
Like the lineage metadata? Yeah, okay. So the question was, can we see lineage from objects beyond what Tableau is connecting to? So as an example, the workbook's connected to a table. Behind that table is it's a view of 2 other tables. The answer is currently we do not get the view constituent tables. Largely that's because Tableau supports 70 plus connectors, and all of those would be a slightly different format, and we're going to have to play a long game of catch up there. But we are investigating ways to add either third-party ETL or kind of database sort of join information into our graph as well. But currently, no.
In our filters, can we do wildcard search, or do we have to target directly the entire name of the tree?
Search. So the question was, can we do wildcard filters, or does it have to be an exact match on name? And the answer is, it depends on which object you're searching for. fields, if I recall correctly, have a... They do not. So for anything that has a text attribute, so a good example is databases. If it has a text object in its filter, then that is a search. So you could do a little bit of wildcard and those types of things. If it does not have a text, then it cannot. So fields are currently not on a wildcard search pattern. Pretty sure. Yeah. Mm-hmm. Yeah, so the question was just double checking, like, that you don't have to do it in this IDE, and the answer is no. I just like to do it here because you get all this auto-generated types and things like that. But it is an API endpoint. You can just call it from any code that you want. It's actually very, very simple. It's much simpler than REST in many ways. All you have to do is type out this little query, and you post it up. There's no complicated response codes or things to follow or interesting XML bodies. You just post this text, and you'll get JSON back. So it's very intuitive for the API programmer. Anything else? Questions? Thoughts, comments, wants, desires? All right. So that's me nerding out on the Metadata API deep dive. If you want to go step by step where I'm not just blazing through everything for the fun of it, then I have a hands-on today and tomorrow where we'll take a lot more time to go through and talk about all those individual concepts. Thank you, everyone.